Okay. So what is my A value, my P value, and my Q value? What's my A value? 2, which means we've done a what? What? Vertical stretch by 2, VS by 2. What's my P value? -4, which means we went left. And my Q, which means we went okay. So Marika, she's going to do the stretch and then the translation, i.e. she's going to do the A value and then the P and the Q, okay? So the A value is a vertical stretch by 2, which means we multiply all the Y values by 2, right? So I'll write her steps down. Number 1, multiply Y values by 2. So here's the graph. Just pick a couple. All right. The center 0, 0 is going to stay the same. This has a Y value of 1. I multiply it by 2, it goes to there. This has a value of 1. Boom. So I get this. So there's step 1 from Marika. Okay. Then, is everybody okay with that? I just multiplied the Y values by 2. That's the vertical stretch. And you can see the graph got stretched vertically. Then she is going to do, she does the translations. So what are the movements? We got to go 4 left and 3 down. Okay. So our second one is 4 left, 3 down. So move the graph 4 left and 3 down. 1, 2, 3, 4. 1, 2, 3. So we end up there. I'll move the other 2 points too. Just so we have. So here's our graph. There's the final graph from Marika. Okay. So then Curtis, being the rebel that Curtis is, decides he's going to do the translations, i.e. the P and the Q first, and then the stretch. Okay? So over here on Curtis's, he does P and Q. So 4 left, 3 down. So I move it 4 left. 1, 2, 3, 4. 1, 2, 3. So he's there. That's his first step. Then he does the A value. So multiply Y's by 2. So we're only going to do the vertex because that's the only one we really need to do. So what's the Y value at the vertex here? -3, right? Times 2. What's -3 times 2? So it moves down to here. So Curtis gets this as a final graph. Exactly. Whose graph is right? Sorry? That is the question. You got 2 different graphs. Which one is right? You're just saying names. Why is it Marika's? That is exactly right. When you're doing, what is bed mass or is it still called bed mass? Bode mass? Something, I don't know, whatever. I don't know. I don't remember that stuff. I just remember what to do. I remember the names. What? Of or I don't know. Well, of means multiplication, but yeah. I thought they changed it. Am I thinking of something else? I don't know. It doesn't matter. Anyway, you do multiplication and division before you do addition subtraction. That applies here, okay? So you do the A values first, okay? You follow BEDMAS. So this is the correct one. This is incorrect, okay? This is the winner. There you go. So if you flip the page, oh, that's a bad photocopy job. Let's see, this is Sadler. Let's blame Sadler. Oh, yeah. I'll write it up here in the corner. You have it. Oh, you actually have it written down, don't you? Top corner, it should say, up here, it should say for you, stretches. Does it say stretches and then blah, blah, blah? Okay. Stretches, reflections, and then translations. Okay. This is the order you go in every single time. You have to remember this order, but it makes perfect sense. You do the stretches and the reflections together because this is your A value. It's multiplying. If it's a reflection, what does that actually mean? The A value is? It's a negative A value. So you say if your A value is -2, you just multiply everything by -2, and that will give you the flip. Okay? And then the translations are the PQ. So all you have to remember is do your A value first, and then you do P and Q. You multiply, and then you add or subtract. All right? So, remember yesterday I gave you the two equations for moving points? Does anybody remember that? So, you probably have room. I'm going to write it over here. Moving points. So, I'm going to amend one of the equations. The x value, what's the only letter, A, P, or Q, that affects the x value? P, right? So it's going to be P plus whatever your x value is. Okay, I'll say x1. That doesn't change. But now, because we have something else that affects the y value, in this case the A, the equation becomes, and you do that first, it's A times y plus your q value. You can write these down. We're going to practice them. I'm not going to make you memorize them. But I will ask you to move some points. All right. Let's talk about, I guess. I'll write what you have. Your A question here looks like this, right? Y is equal to -1/4 x squared. Is that what your question is there? Okay. Tell me what we have done. What is the transformation? So, is this -1/4 A, P, or Q? It's A. Okay, A is -1/4. What does the negative tell you? It's going down, but what do you say that the transformation is? It's a reflection or a flip. The 1/4 tells you it's also a, whoever said that, compression. But we can just say vertical stretch by 1/4, but we know it is a compression. Okay? All right. So the negative tells you it opens down, and we've done a vertical compression. All right. B. 1/3 y is equal to x plus 6 all squared. What's wrong with the way it's written? What's our general equation? It's this. There you go. The a is on the wrong side. That's our general equation. It has to look like this. So you got to get rid of the a. How do I get rid of the 1/3? Divide by a third, or just multiply the 3 up. Same thing. Okay? If you just multiply this side by 3, they cancel, and multiply this side by 3. So I get y is equal to 3 times x plus 6 all squared. So a value is 3, which means we did a. What does an a value of 3 mean? Vertical stretch by 3. It means you've expanded it. What is this 6? That's a p-value, right? Is it positive 6 or negative 6? Perfect. P is negative 6, which means we went left. Okay. Let me give you some practice. Actually, let's do one more and then let's practice. Okay. Okay, so we start with y is equal to x squared. We always start with y is equal to x squared. And then we do the following. We reflect in the x-axis. As soon as I say a reflection, what does that mean the a value is? Negative. So we know our a value is going to be negative. Negative what? We do a vertical stretch by a factor of a third. So what's my a value? Negative 1/3. We go translation 7 units right. So what letter is that? That's your p-value. And is it positive or negative? Positive. That's it. Don't worry about this bit. Okay. What is the equation of the image? Basically the same. What's the new equation? All right. So everything relates to this. Once you know A, P, and Q, if I don't say anything about Q, what is it? It's 0. Because it's adding, right? It can be 0 because you're adding. A, if I don't say anything about A, it's a 1 because you're multiplying. Then you just plug it into the equation. So it's y is equal to negative 1/3 x minus 7 all squared. What are the coordinates of the vertex? Not negative 7. 7 and 0, right? P and Q. Don't find the value of T. It's just part of the question that they're trying to. Don't worry about it. Okay, let's do this table and then we're move on to another lesson. Okay. We're going to complete this table. So here's our function. Negative x plus 3 all squared minus 4. What's the vertex? Because the vertex is always PQ. Is it going to be a max or a min? Well, what does this negative mean? It's flipped. It's opening down, right? The graph hasn't. Why won't you draw? Negative 3, negative 4. So it's over here. It opens down, right? So that's got a maximum. So when it opens down, it has a maximum. Okay? And the max is what? Yeah, max equals negative 4. Because it's always the Q value. Now, whether it's a max or min depends if it opens up or down. If it opens up, it has a minimum. If it opens down, it has a maximum. Axis of symmetry. That's the line that splits it in half. -3, it's always it's like that. It's always the p-value. So it's x is equal to -3. What's the domain for every single parabola? XER are all real numbers. What is the range of this graph? I.e., what is the y values, the possible y values? So we said that there's a maximum of -4, and then what does the graph do? Does it go up or down? It goes down. So all your y values are going to be bigger or smaller than -4? Smaller. So the way you write that is y is less than or equal to -4. No, you can just write that. If you want to do it the other way, if you like the other way, then you would write, it's going to go from -infinity to -4, not including infinity, but including 4. You can worry about that next year if you don't like that method. All right, next one. Let's fill this out quickly, and then I'll give you a couple, and then we're done. What's the vertex? 9, 0. Does it have a max or a min? Of what? Perfect. Axis of symmetry? Domain? The domain? It's always all real numbers. What is the range? Greater than 0. Perfect. Greater than or equal to, that is true. Okay. Here's your questions, and then it leads into break. Numero 1. Just 1A, that's it? That's all you want to do? 1A, 2. And 9. Yeah. 1, 2, 9, please. 1, 2, and 9. How's that? Sorry, not 1, 2, 9. So page 294. We know that the standard equation of a quadratic function is this. Okay? And what we've been doing is I give you the equation and then you sketch the graph. Now we're going to do the reverse. I'm going to give you the graph. You got to figure out the equation, which is actually more valuable of a skill because in science and things like that, you get a bunch of data points. You would graph them. Can't do much of that graph until you know the actual equation of that function. All right. So what do P and Q represent? Sorry? The vertex, right? P and Q are the vertex. So the vertex equals PQ. So on this graph, do I have the vertex? I do. -1 and 2, right? So that is P and that is Q. So I already know what P and Q are. Do I know what X and Y are? I do. They give you another point. That and that. So the only thing I have to figure out now is A. To do that, plug your X, Y, and your PQ into the equation. So if we start with y is equal to ax minus p all squared plus q, my y value is 1. My a value is what we're trying to find. My x value is -3 minus my p value, which is -1, all squared plus q, which is 2. So now we got to clean this up and solve for a. So do what's in the brackets first. -3 minus -1. So -3 plus 1 is 2 squared plus 2. What's -2 squared? 4. So I get 1 is equal to 4a plus 2. Subtract off the 2. So I get -1 is equal to 4a. And then divide out the 4. So -1/4 is equal to a. So this equation is y is equal to -1/4 x plus 1 all squared plus 2. Okay, so when you write the actual equation, you leave the x's and y's out, and you just put in the a, the p, and the q. Yes.
The x and y that you used, can that just be like anywhere on the
Anywhere on the graph, but they give you this one, right? So, well, if it's, but it could be anything. If you knew, that's the only one you actually know, though. But if it was any other point that you knew, you plug in anything, and you get the same answer. Okay. But ask yourself, does an a value of -1/4 make sense for this? Why? Because it's negative and it's opening down. If you got a positive a value, you know you did something wrong because that should say it opens up. Okay? All right. Let's go back. So that's when you have a graph. Okay? You go back to the front page here. They're just telling us. Okay? So we have a quadratic function with a vertex of -2 and 8. The vertex is P and Q. They tell us it passes through the point, -1 and 7. There's your x and your y. Plug it into the equation. 7 is equal to a, -1 minus -2 squared plus 8. I'll let you solve that, and then I'll put the answer up.
The negative sign is calculated for the
And then if you could sketch the graph, that would be awesome too. Ready? Is that it? Yes, yes, yes. So your a value is -1. You can just put a negative outside. You can write -1 if you really wanted to. Doesn't matter. And if you sketch the graph, you know the vertex, you know it just opens down. That's it. Is that okay? All right. Numero 1. Just 1a, should say. 2, that's not it. And 5. 1a, 2, and 5.
I got a
12, 10, you mean 11, 10?
or 11.
All right.